Hi, in this video we will do some examples for another trig substitution. This is x equal to a tan theta. This substitution works when your integral integrand has a term like this, or x squared plus a squared. Then if you set x to be a tan theta, you will turn this function under the square root into, well, a squared. See, I can factor out a squared and I'll get 1 plus tan squared. And, well, we know that 1 plus tan squared theta is secant squared theta. So that will give me a squared secant squared theta, and then this is a secant theta. So as you can see, by this substitution, we get rid of the root, which is the part that makes the integrand difficult to be integrated. Okay, let's try this in some examples. Here I see that there is the term x squared plus a squared. So here a is 2 squared is 4. So then we set x equal to 2 tan theta. Plus sign is what tells us to use 2 tan theta. And here you can use 2 cotan theta as well, but we'll stop with this one. Then as a result of that, dx is equal to 2 secant squared theta d theta. And now I can go and turn my integral into theta integral. In the denominator, I will have 4 tan squared theta. Inside the root, I have 4 tan squared theta plus 4. In the numerator, well, dx, I'm replacing it by 2 secant squared theta and then d theta. Let's do more simplifications here. So I will have 2 coming, so here that will give me 2 secant theta, and that will cancel with one of the powers up there, and that will cancel with that. So I will get secant theta over 4 tan squared theta d theta. Very nice. Now let's just, well, we have to integrate this one here, yes? So what we need here, the approach for this one will be, well, just simplify the terms in terms of sine and cosine. So I have 1 over cosine theta here, then there's 4 times sine squared theta over cosine squared theta d theta. And then you cancel this with that one, and what you will see here is integral of cosine theta over 4 sine squared theta d theta. So this is a trig integral, and what you can see here is that I have 1 over 4 sine squared theta cosine theta d theta. You see the derivative of sine is cosine, so we can go ahead and use the substitution u equals to sine theta, then du is equal to cosine theta d theta. Okay, so that would turn, so this is just regular u substitution. And my integral now is 1 over 4u squared du. And well, that is easy to evaluate. That is just negative 1 over 4u plus c. Put back in the theta form, so 1 minus 4 over sine theta plus c. We have to do one more step. So here you see that we set x to be x over 2 tan. So if you, we set x equal to 2 tan theta. So if you use the reference angle, so the theta is here, then tan theta, which is opposite to adjacent, is of this form. And then you have here will be x squared plus 4. Now I am looking for sine of that theta. So using the reference, use ref angle, triangle, and turn back everything in terms of x. So it will be negative 1 over 4, and the sign here is x over x squared plus 4 plus c. And as you can see, well, this can be simplified one more step. This is x squared plus 4. There's a negative sign there over 4x plus c. So the key point here was that we use this trig substitution, turn integral to a trig integral here, and then use the u substitution to find that integral. And here we are. We turned everything back, and and we have the final answer for the tan. Let us do one more example here. I have integral. Look at the denominator. Note that in the denominator we have 4x squared plus 9 to the power 3 over 2. So you may say, oh, where is this whole a thing? So what? Oh, to the power 3. I already put that there. To the power 3. So what you need to see in this case is that if I factor out 4, I will get root 4 and then x squared minus 9 over 4. Everything to the power 3. Oh, plus. And well, as you see here, this is now our a squared. In other words, let x to be 3 over 2. A squared is 9 over 4, so a is 3 over 2 tan theta. Okay, then comes out from that dx is going to be 3 over 2 secant squared theta d theta. This is definite integral, so we have to change the limits as well. X, when x is equal to 0, so this is tan theta must be equal to 0, so that means that theta must be 0. If x is equal to 3 root 3 over 2, then we have as a result of that, while you simplify what is the angle whose tan is root 3, that theta is pi over 3. Okay, so now I can turn my integral into, so this is the integral into the theta integral. and 0 to pi over 3. In the numerator, I have 3 over 2 tan theta to the power 3. In the denominator, we have, you plug it in there, you will get 4 times 3 over 2 tan theta squared plus 9 to the power 3 over 2. And for dx, we have 3 over 2 secant squared theta d theta. Okay, so now let's go ahead and simplify the terms. This down here will give us 9 tan squared theta plus 1, which is 9 secant theta squared, but you can cancel those powers and you just write it as to the power 3. Here I have 3 over 2 tan theta to the power 3, and that is 3 over 2 secant squared theta d theta. So as you can see, what happens here is, okay, first let me do the simplification. These 3 to the power 3's will go away. There will be no power 2, that will cancel with that. I'm doing a little bit strange simplifications here. And then here in the numerator will 0 pi over 3. So this is 10 to the power 3 theta over there is a 2 coming from there to the power 2, and there's 3 now there, so 3 over 4. Oh, actually I can do a little bit more there. So that 2 and that 2, that will give us 16, and there's this 3 remaining that we'll put it there. And here I have secant theta d theta. Okay, nice. So you can go ahead now. You have this trig integral. We have to evaluate that. But one thing that you can see is tan to the power 3 theta over secant theta can be written in terms of sine and cosine, and what you will have here would be sine to the power 3 theta over cosine squared theta d theta. Okay, so let me get back to this part. So 3 over 16 integral 0 pi over 3. I will have sine squared theta here, cosine squared theta, and then there is one power that I am separating, because you see this piece is derivative of u being equal to cosine theta, and I can use the u substitution. U sub set u to be cosine theta d theta, then cosine theta du is going to be minus sine theta d theta there. And then we can change the substitutions, so the limits. Theta is 0, then that will imply that u is 1. Theta is pi over 3, that means that u is half. So my integral then turns into 3 over 16 integral 1 to half of there's a minus sign. I'll put it outside du. And here, look, sine squared, I can write it as 1 minus cosine squared theta. So this will be 1 minus u squared over u squared. And that is just an easy integral to evaluate, because I can simply go 1 over u squared minus 1 du, and that will give me minus 1 over u minus u, and then go from 1 to half. Okay, so these values are easy now to evaluate. So this is, let me do it there, minus 1 minus 1. That's the first term, minus the second one. Oh, I should have done the other way around. So this will be plugging half first, so that will give us minus 2 minus half minus negative 1 minus half. Okay, so that's the number we are looking for. So this part here is negative 2, then 2 here, and here I have 5 over 2, negative 5 over 2. Oh, actually, yeah. And these two cancel. We get from this whole thing negative half. The final result is going to be plus 3 over 32. Okay, so use substitution, you do apply and then do several steps, but the key point was to start with this substitution. Okay, let's do one more example. Well, this time again we have root of some quadratic form. Here we have to start with completing squares. So t squared minus 6t plus 13. I can complete this by doing plus 9 plus 4. So I put plus, I write 13 as 9 plus 4 because 9 with this set here gives me t minus 3 to the power 2 plus 4. So my integral then would turn to t minus 3 squared plus 4. I need to do one substitution first. Set x to be t minus 3. Dx is going to be dt in that case. So I will have dx over root x squared plus 4. Now it's time to go ahead because I have x squared plus a squared. We can use substitution, trig substitution. X equal to 2 tan theta, and obviously that will give us dx equals to 2 secant squared theta d theta, and my integral would turn into secant squared theta. There's 2 here, d theta. In the denominator we will have 4 tan squared theta plus 4, and that will give us actually 2. Oh, why did I turn it to sine? I don't know. In the denominator we will have square root of a 4 secant square, and as you can see I can now cancel this with that and this with that, and the integral will be simple integral of secant theta d theta. Well, we know this is an integral from the table, so this is ln of absolute value of secant theta plus tan theta. Okay, now we have to go back to x. Remember that x over 2 is tan theta. So if I draw the reference triangle, theta here, x here, 2 here, then this will be 4 plus x squared. And secant is 1 over cosine. So this will tell me this is ln of 1 over cosine. Here is 2 over that, but that will give me 4 plus x squared over 2 plus tan theta is obviously x over 2, yes? And now I can go back to t integral by plugging in, what was it? So for the t substitution was here, yes? T minus 3 is x. Now for x we can plug in t minus 3, yes? 4 plus t minus 3 squared over 2 plus t minus 3. And that integral, if you expand it inside the square root, you will get what we had at the beginning, t squared minus 6t plus 13 over 2 plus t minus 3 over 2 plus c. So these were some more examples of trig substitution when we have square root of a squared plus x squared in our integral.